right, so we're solving inequalities. So the first step is, remember, we want to pretend it's an equal sign to, so we're going to pretend it's an equal sign. And we're going to find the boundary points. So if I pretend it's an equal sign, that's just a linear equation. I can solve that. I can add 5, divide by 6, so you get 5 halves. So divide by 3, it gives you 5 over 2. So now we take that and we put it on a number line. So we'll say that this is 5 halves, right? This is 0, this is 1, this is 2. I don't know, this is 3. I don't know. I'm just emphasizing. But we put on a number line. It's 5 halves. This tells you if it's an open circle on that boundary, so closed circle. And now I just need to test true and false. So if I plugged in 0 or if I plugged in 3, I just want to see if it's true or false. So if I plugged in 0, I get 6 times 0 minus 5. Is that less than or equal to 10? Negative 5. Is that less than or equal to 10? That is true. So this side is true. Now I need to test this side. So I'll test 3. 6 times 3 minus 5. Is that less than or equal to 10? So that gives me 18. That's 13. That's false. So this side is false. Now your solution is always the true boundaries. So in this instance, because that's true, that's why I'm shading it. So my answer is the shaded region, which is negative infinity to 5 halves, including 5 halves because it's equal to. Now, it's important that we change it to the equal sign just because it's just, we know how to solve quadratic equations. We know how to solve absolute value equations. That's all we're doing. We're just solving these different types of equations. So like, for example, we're going to pretend it's an equal sign. I can factor that, a times c, negative 24, factors of negative 4 that add to negative 5. That's what, negative 8 and positive 5, right? Those are the two factors. Sorry, 3. I was looking at the 5 as I was saying that. And so this becomes x minus 8 and x plus 5, right? If you go through and factor it. So that means set each one equal to 0. You get x equals 8, and you get x equals negative 5. Those are my boundary points. So negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, dot, dot. We'll just say this is 8. Which means this is 9, 10. So it's just a number line. This is negative 6. This is negative 7. All it is a number line. So now we test true or false. We see which regions are true, which regions are false. So I can plug negative 6. You get negative 6 squared minus 5 times negative 6 minus 24. That's 36 plus 30 minus 24. That is greater than or equal to 0, so that's going to be true. If I plugged in 0, I get negative 24 is greater than or equal to 0, because 0 minus 24, that's false. So this is false. And then I can plug in 9. 9 squared minus 5 times 9 minus 24. 81 minus 45 minus 24. That's going to be greater than 0. So that is going to be true. So we shade what's true. And so my answer is going to be negative infinity to negative 5. Union from 8 to infinity. Now another way to look at this, and I find this very helpful, is think of this as positives and negatives. So this statement here, greater than or equal to 0, numbers that are greater than or equal to 0 are positive numbers. So actually, positive numbers are what's true. Now it just makes it a little quicker if we want to think of it in this terms. Because if I plugged in negative 7, I'm going to rewrite it down here. if I plugged in negative 7, I get negative 15. If I plugged in negative 7, I get negative 2. Negative times a negative is a positive. This is positive. If I plugged in 0, you get negative 8. If I plugged in 0, you get positive 5. A negative times a positive is a negative. If I plugged in, say, 9 minus 8 is 1. 9 plus 5 is 14. Positive times a positive is a positive. Notice the positive values are true. It's just a little easier. It's a little quicker by thinking of it that way. And when we're dealing with the zero product principle, you can use that method every single time. Now absolute value. So remember, we're going to pretend that this is an equal sign. So remember, we want to isolate the absolute value. So subtract 2. Divide by a negative. Or divide by 2. Now, I could do the whole plus or minus thing to get rid of the absolute value. Oh, I need to do equal, sorry. Now we have an issue here. And the issue is, when can an absolute value equal a negative number? It can't. So right now I have no solutions. If you went through and you solved this, you're going to get, x equals something, x equals something. If you plugged them back in, it won't work. You're going to get an extraneous solution. So we just need to be careful of that. Now, because there's no solution, now we just need to test the entire number line. There's no boundary points at all. So if I test one value like 0, 4 times 0, so negative 8, absolute value of negative 8 is 8. 8 times 2 is 16. 16 plus 2 is 18. Is 18 less than or equal to negative 3? That's false. So the entire thing is false. So again, there's no solution. Now another way of thinking of it would be, when can an absolute value, right, especially when I isolate it, when I get it by itself, if I include the symbol again, when can a positive number be less than a negative number? Never. And so even right there, the logic doesn't make any sense, which is the reason why I would say no solution. Problems like number 4, again, if I pretend it was an equal sign, if I subtract and square root, you're going to get imaginary numbers, which again means no boundary points. So there's no boundary points on this line, so I can test any value like 0 and see if it's true or false. 0, so I get 1. Was 1 greater than 0? That's true. So the entire thing is my answer. Now, every single value that you plug in, it's going to be true. I can plug in 5. 5 squared plus 1, 26, greater than 0. I can plug in negative 5. Negative 5 squared, that's 25 plus 1. That's 26. That's also greater than 0. There's not a single number that you can pick that won't make that statement true. And so my answer is negative infinity, positive infinity. For number 5, the secret here is when we pretend that it's an equal sign, to get rid of the absolute value, remember, it's a plus or minus. So you're going to get x plus 5 equals x plus 5. And then you're also going to get x plus 5 distributing the negative equals negative x minus 5. Now this, well, I don't get a value for x there. Nothing. But for here, if I get x plus 5, I can add the x. So I get 2x. I can subtract the 5. You get negative 10. So x equals negative 5. Now, I have to test it. So let's plug it in. So if I plug in this negative 5, I get negative 5 plus 5. That's 0. If I plug in negative 5, oh, is 0 less than or equal to 0? No. Okay, but it could be a boundary point, right? Because it's just an open circle. So negative 5, negative 6, negative 7, negative 4, negative 3. And now we test true or false. So if I plugged in negative 4, negative 4 plus 5 is 1. Negative 4 plus 5 is 1. Is 1 greater than 1? That is false. If I plugged in negative 7, negative 7 plus 5, that's negative 2. Negative 7 plus 5 is negative 2, but the absolute value of that is positive 2. So is negative 2 less than positive 2? Yes. So this is true. So all these values are true. And so my answer is negative infinity to negative 5. For a problem like this, you can't distribute the x squared or the x. So remember, we want to get rid of the, so this is x times plus or minus x plus 5, which is greater than or equal to negative 6. So this x goes with the positive version. And then this x goes with the negative version. Solve for each one. Solve for each one. You may have to use the quadratic formula. You're going to have to try factoring. And then same idea here. You can get rid of the x by doing the plus or minus. And then this is one of those where you would have to, you get x squared plus x is greater than 0. And x squared minus x is greater than or equal to 0. Because you have to bring it over to the other side. So I can add x to each side. I can subtract x to each side. And then the way you factor it, you factor out the x. Remember, we're pretending they equal 0. And so you get x equals 0 and negative 1. And here you get x equals 0 and positive 1. And so those are your boundary points. You can test them. 0 works, negative 1 works, 1 works. So then those are our boundary points. And that means you have to test values in between, like negative 1/2, positive 1/2. These are closed circle. So if I plugged in negative 2, negative 2 squared is 4. Is 4 greater than or equal to negative or positive 2? That is true. If I plugged in negative 1/2, is negative 1/2 squared? That gives you 1/4. Is that greater than or equal to 1/2? That's false. So that's false. If I plug in positive 1/2, is positive 1/2, that gives you 1/4 again. Is that greater than or equal to 1/2? That's false. But then if I have 2, 2 squared is 4. Is 4 greater than 2? That is true. So this is my answer. And so that's negative infinity to negative 1, union 0, union 1 to infinity. Again, the difference quotient, you can see the previous lessons for these. Remember, the rational is the common denominator. This is the conjugate. And then just remember that x plus h squared is x plus h times x plus h.